Okay. You have to start off by writing the balanced equation. That would be aluminum plus hydrochloric acid. Question, is aluminum monatomic or a diatomic element?
Monatomic.
Here's your list of diatomic elements. If you need to write that down, go ahead and write that down.
Are you still videoing?
I am.
No.
It'll be okay. All right. Take a look at the periodic table. If you look at this periodic table over here, notice how each element, they're different colors, right? You have red, black, blue, and then white. Aluminum is what color? Black. So what state of matter would that be? So this is solid aluminum. Now, hydrochloric acid, since it's a compound, we have to look at our solubility rules. Chlorine is aqueous. So this is aqueous, and you should really know that anyways. It's always aqueous. When you look at this, aluminum is an element, hydrochloric acid is a compound. What kind of reaction would that be? Element plus compound. Single replacement. Aluminum replaces hydrogen. So that gives you AlCl. Does anybody know the charge of aluminum? +3. Chlorine is -1. So +3, -1. That gives you AlCl3. If you look at your solubility rules again, chlorine, aqueous, no exceptions that are valid here. And then hydrogen. So is hydrogen diatomic or monatomic? Diatomic. Now if you look at hydrogen on the periodic table, what color is it? What state of matter would that be? Gas. So the next step, we need to take what we know, which is 30.9 grams of aluminum. Oh, we didn't balance our equation, did we? We need to balance the equation. Yeah, let's balance this equation. Now we're balanced. What did it say we're looking for in this problem? Gas. So which product is our gas? H2. So when you look at the flow chart that takes you from substance A to substance B, substance A is always the one that's given to you, in this case 30.9 grams of aluminum. So substance A, we're looking for gas, which is hydrogen. That's going to be substance B. So we have to set up our flow chart. But it usually would be volume. Almost every time it's volume, but this time we're actually looking for the mass, which is not very common to ask for that, but in this case we are. So we're going from mass of A to mass of B. What's your next conversion factor after this? Yep, a mole of aluminum is equal to the molar mass of aluminum. And then, of course, if you don't know that, that's where we got it. So what's the next conversion factor? Mole B over mole A. So mole B, 3 moles of H2 over 2 moles of aluminum
That 3 was there, like there's no number of ways to be 1.
That's right. Yep. Good thing you got that driver's license though, right? Yeah. So if you start off with grams of aluminum, right, that cancels. Moles of aluminum cancels. So now we're left with moles of hydrogen. So we've converted from aluminum to hydrogen. So when we get the molar mass in our next step, we're getting the molar mass of what? Hydrogen. So that's 2.016 grams of H2 over a mole of H2. Moles cancel. Why did I go with 2 instead of 1? You know, when there's 2 H's, right? So your periodic table says 1.008, but since there's 2 of them in H2, you double that. Is anybody going to complain if I just show you what I punch in the calculator? I mean, some of y'all probably have it, but I don't think it hurts to see it. We haven't done this in a while. Okay. Okay, so you got to be polite if you want the calculator to cooperate. So 30.9. Are we going to multiply or divide by 26? Yeah, divide by 26.982 times 3 divided by 2 times 2.016. How we doing? I'm just waiting for everybody to plug it in. How many? We have 3 sig figs, 4. So it's going to be 3 sig figs. So we'll call it 3.46 grams of H2. That's your answer.